These are pretty low power LED bulbs, so how do they work and some of the things that you can check if you feel like repairing one. A simple board with just an AC capacitor, a DC smoothing capacitor, these 4 diodes for the full bridge rectifier, and these LEDs in series. It's almost the same approach as using a resistor to limit the current for this LED. But instead of using a resistor, we are using a capacitive dropper. When using a resistor, it's very lossy as the dropped voltage is converted to heat. But when using a capacitor, ideally there are no losses. 40 volts AC in, our capacitive dropper, the bridge rectifier made up of the 4 diodes, the DC smoothing capacitor, and those LED bulbs in series. A capacitor connected in series with the circuit offers some form of resistance depending on the AC frequency and its capacitance. That form of resistance, we call it capacitance reactance. Frequency of AC and the value of the capacitance. 29.82 nanofarads. Divide by 1 billion to convert nanofarads to farads. .9 kilo ohms. The current provided by the capacitor is the voltage divided by its resistance. The current provided by that capacitor has been limited to a maximum of 6.01 milliamps RMS. This capacitor not only limits the current, it drops most of the AC voltage. The AC voltage going to the bridge rectifier is much lower. Then after the bridge, we have a smoothing DC capacitor. So if one LED is blown, it will break the circuit, the flow of current, and the other LEDs will not work. The LED bulb is flickering. Check on this capacitor. Also check the bridge rectifier. It could be that it is not rectifying both halves of the AC properly. If the LEDs and the capacitor and the bridge are okay and it's still not working, check on the capacitive dropper. It may have developed a very high internal resistance, reducing its capacity and increasing the resistance. This will reduce the current by a very huge margin, causing it not to work.